Alright, today I'm going to be talking about 8-6, absolute versus conditional convergence. I don't know. I hope this to be a short video. We'll see. We will see. So, many convergence series have some negative terms, right? Like that's been a pattern throughout the last two units. Maybe they alternate, maybe it's some other pattern. Maybe it's like every other. Maybe it's negative, negative, positive, positive. Maybe it's every three. Who knows? It doesn't matter. It doesn't really matter for what we're talking about. But having those negative terms made it more likely to converge. And I'll talk about that as we go through. Taking the absolute value of each term of a convergence series with some negative terms makes a new positive series. Makes a new series that's only going to be positive, which is less likely to converge. And why is it less likely to converge? Less likely. Because the sum, the new series, will be greater without those negative terms. Right? It's like, right, if you have a series of payments that went 1 minus 5 plus 3. You got $1, you spent $5, you got $3. And then you've changed it to this. This was some nice number. This was actually a pretty calm number, like -1. A number where maybe if the pattern continued, and I'm not saying it was a really easy to see pattern, but if the pattern continued, you might stay around 1, right? If you kept spending more money than you make, okay, we can make it better. Minus 2 plus 5, right? If you kept alternating between spending a lot and making a lot, you'll probably stay around 0. Whereas this person who's only spending, where I've changed all the negative terms into positive terms, is now going up, 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 up. Right? This sum is less likely to converge because it beats every term. It's the same or greater at every term, and that'll be important. Okay. I'll talk more about that in a second. If the new positive series is still convergent, the original series was called absolutely convergent. Absolutely convergent, absolute value. I converge so fast that even the absolute value of me converges, right? Like, I'm so great, I'm so convergent, because even if you try to stop me from converging, even if you take away all my negative bits, I still converge. That's how convergent I am. Absolutely. If the new positive series diverges, the positive series diverges, the original series converges, the positive series diverges, then we're talking about something that's called conditionally convergent. If a series converges after taking the absolute value, it's guaranteed to also converge with no absolute value. And this will be a powerful technique. Sometimes it's easier to check the absolute value version than it is to do the alternating series test. Okay? And what if the original series diverges? Then they both diverge. Okay. And what's happening here, you can keep these numbers in mind, but you know, they're not real series. What's happening here is we have this original series, we'll call it red, where it was some bunch of numbers being added up, right? And then I have this new series, green, which is the absolute value of the red terms. And now these two series are less than or equal to each other, for the reason we talked about before. At every single point, I'm either adding the same number or I'm adding a number that's, I don't know, twice as big in some sense. Alright? I'm adding the positive version of the negative number. Either I'm adding 1 or I'm adding the positive 5. I don't know. Let's just show them. So, this might look similar to what we would have called a direct comparison test. It's a direct comparison test type thing, where since this is bigger, if this converges, the bigger one converges, makes the smaller one converge. And likewise, if the smaller one, if the original guy diverged, the smaller one diverging makes the bigger one diverge. Make sense? Alright, I hope so. Like, this is why it's short. There should only be the 3 examples. Make sure you do 8-6. Make sure you do 8-6. Make sure you do 8-6. There's lots of fun from this unit. Don't forget the Chapter 7 stuff. That's really important. Okay, so I look at each of these series. And in general, you might have some idea of what's going on here. You should always check if it converges a little bit in your mind. Like, I wonder if this converges or not. Well, it's alternating. That sure is good. That's good for us. And in fact, if you've been studying, if you've been watching all these videos closely, you'll recognize that this is what we would call the alternating harmonic series. Which we know converges. Yes, that's okay to write on the AP test. It's a very famous series. They'll know what you mean. It's an alternating harmonic series that converges. How could you show it? Well, you could use the alternating series test. Is the limit of the absolute value going to 0? Are the terms decreasing? Yep. Okay, so this converges. So now I'm going to look at the absolute value. The series made by taking the absolute value of it. Which is that guy. And you may have already known that this guy is what we would not call the alternating harmonic series, but the OG harmonic series. Which diverges. So this is the first kind of case. The original series converges. The absolute series diverges. So you say the original series converges conditionally. I anticipate questions in class today. How could they test us on this, really? Well, this is traditional multiple choice. Here's 3 series. Which of them converge absolutely? 1 only, 2 only, 1 and 2, 2 and 3, or all 3, you know? The hard questions to ask. Alright, 2 is a classic case of, well, that's hard to think about. It's not alternating. I need you guys to know that even I don't know really. Well, I do. Cosine 1, cosine 2, cosine 3. Those are all positives. 4, 5, 6, all negative. Oh, wait, no, that's not true. See, even I messed up. Cosine 1's positive, cosine 2 and cosine 3. And cosine... Like, it doesn't have a nice pattern. Okay, that's too early to do that. Obviously. So, instead of looking at this guy, let's just try to take the absolute value. Because you know what? If the absolute value guy converges, the whole thing converges. Anytime I see cosine, anytime I see sine, I'm going to think about doing the absolute value. I really am. No, I want a different color. So, let's represent the absolute series in orange. Now, why? Why cosine and sine? Why would I want them? Why would I want to use absolute value there? Because I know, thinking, that the absolute value of cosine makes it always less than 1. In fact, cosine is always less than 1, but if you look back at the direct comparison test, I believe we always needed 2 positive series. This terms had to always be positive. So, that's good. So, direct compare to this bad boy. Yeah, no. Where I replaced all the top numbers with 1. This is going to be less than 1, equal to 1, right? For every single term. Every single n that has to be less than 1 because cosine only ever maxes out at 1. So we're going to compare to this, which is a p series. This is why this is a great lesson to end the unit on. P series, p equal to, converge. Converges by the p series test. That kind of goes without saying if you write it like that. You identify as a p series, you identify what p is, you say it converges. Boom, mic drop. Alright. So we're going to compare these two. Now, which one's bigger? I've already talked about this. Rahul got his bag stuck in the door. It's pretty funny. I'm going to compare it to or rather I know this is the relationship that's true. And again, this is the relationship I wanted. If I'm using a convergence series with a direct comparison test, I want it to be greater. I need it to be greater. Because I need to be greater and converge, and that traps the bottom series and makes it converge. It holds it down. Alright, so converges, greater, so this guy, the original series, well, no, the absolute value series guy converges by the direct comparison test. You would need to state that. Shrink it. I don't know, right there. Erase this. And again, the idea is, since the absolute value series converges, so the original series, the OG series, converges absolutely. Okay? And we never even have to check it. So it's kind of like doing another direct comparison test. If you're really stuck on a problem and you can't figure out how it converges, we're doing that. We're probably going to take the absolute value and check that. It's probably a trig thing. It's probably really easy to check after you get rid of the trig function. Okay, now this one's really hard. There's a couple ways to do it. One way is to do the ratio test. But to kind of tie this back together with Unit 6 and L'Hopital's rule, the idea I have when I look at this series is that exponential over polynomial, bad news. Now, I have enough mathematical confidence and knowledge to know for a fact what's going on here. I think a lot of people struggle with the idea that up here and down here is confusing, right? Everything's switching places. But what's changing? N is changing. The exponent's getting bigger and bigger and bigger. The input's getting bigger and bigger and bigger, but the exponent's staying the same. So this bottom thing, like I said, is a polynomial. This top thing is an exponential. So that's what tells me. That's what gives me the confidence to do, well, let's take the limit. Maybe I'm wrong, but I'm not. Exponential over polynomial. It's definitely infinity over infinity. But, in fact, because this infinity is fast, and this infinity is slow, you actually know that this limit, as n goes to infinity, e to the n over ne equals infinity. So, diverges by NTT. So, that's it, really. I saw last year, definitely some kids were writing, oh, it diverges, and now I'll check the absolute value series. You should know really quick, absolute value is not doing anything here. But either way, there's no such thing as diverges absolutely. If the original guy diverges, everything diverges. Okay? So those are the three types of things that can happen. Make sure you do 8-6. See, I told you this would be a short video. So happy. Again, as you work through 8-6, come and ask questions. I'll be here for you. I don't know. Have a nice day. For me, it's Friday, so I don't know. Have a nice weekend. I don't know when you're watching it. Have a nice day. Have a nice night. Keep up the hard work. Good job, guys. Bye-bye.